All right, we are working in Chapter 7 of our textbook. We're on Learning Plan 4.1, multiplying and dividing rational expressions and functions. We're going to define rational expressions and then describe their domains. We're going to write rational expressions in lowest terms, multiply rational expressions, find reciprocals, and then divide them. So what is a rational expression? Well, if you notice, rational has the word a fraction kind of in it. It's an algebraic fraction. So here's some rational expressions. Notice the numerator is a polynomial and the denominator is a polynomial. So rational expressions are the set of all p divided by q such that p and q are polynomials, and the most important thing is the denominator can't be 0. So the domains of our denominators can't be 0. Well, in other words, for this example, x minus 5 does not equal 0. Add 5 to both sides. X does not equal 5. So for each of these, tell what are not in the domain. Then give the domain in set builder notation. So x squared minus x minus 6 does not equal 0. Factor that. X minus 3, x plus 2 does not equal 0. So x does not equal 3 or negative 2. So it's the set of all x such that x does not equal 3 or 2. This one over here, 5 does not equal 0, which it doesn't. So it's the set of all x. That's the domain there, because x can be any number. All right, try these, and then when you're ready, press play and I'll show you how I did them. All right, so for the first one, x squared minus 4x minus 5 does not equal 0. X minus 5, x plus 1 does not equal 0. X does not equal 5 or negative 1. You should be able to factor to get from here to here in your head by now, at least on these easy ones like this one. For the second one, 2x squared plus 1 does, we didn't write it in set builder. Set of all x such that x does not equal 5 or negative 1. All right, for the second one, I'm going to change colors. 2x plus 1 does not equal 0. 2x squared does not equal negative 1. X squared does not equal negative 1/2, which obviously it doesn't because this is always going to be positive. So this is the set of all x because it doesn't matter what x is, it's not going to, denominator can't be 0. And then you try this one. Okay, so x minus 8 does not equal 0. Add 8 to both sides. X does not equal 8. Next one, writing expressions in lowest terms. Well, a rational expression is a quotient of two polynomials. So if we divide the top and bottom by that common polynomial, we should be able to simplify that polynomial. So the first thing that we're going to do is factor the numerators and denominators and then divide out the common factors. Make sure that only common factors are divided. All right, so for this first one, the numerator factors into y plus 2, y plus 3, y minus 1. The denominator factors into y minus 2, y minus 1. Notice they both have a y minus 1 in them, so our simplified fraction is y minus 3 over y minus 2. For the second one, the numerator is in lowest terms. The denominator, well, you can't factor that either. So this is in lowest terms the way it is. For the last one, 1 plus p cubed factors into 1 plus p 1 plus p squared. Oops, this is supposed to be a minus p. Over 1 plus p. So we can factor this against this, and we'll get 1 minus p plus p squared. Remember those, if you're having problems factoring cubes, they are listed in your textbook on cubes. Where are they? Factoring trinomials. Section 3, I believe. Yes, it is. It's on page 334 and 335. All right, next one. You do this one, and when you're ready, I'll show you how I did it. All right, the numerator, this times this is 6. So 3a squared minus 7a plus 2. Split the middle term into negative 6a negative. What two numbers multiplied equals 6, added equal negative 7? Yeah, negative a. And then if we put in the parentheses, that'll change this to minus 2, 3a squared. So that this factors, we can factor out a 3a out of the first ones, and negative 1 out of the second ones, and we're left with a minus 2. Then for the denominator, a squared plus 2a minus 8 factors into a minus 2a plus 4, a plus 4 minus 2. These cancel. So our answer is 3a minus 1 over a plus 4. I'm going to change colors for the second one. Numerator factors into t plus 2, t squared plus t, 2t, minus 2t plus 4 over t plus 2. So our answer is just the numerator t squared minus 2t plus 4. Last one, we can factor a m out of the first ones and a n out of the second ones, and we're left with a minus b. In the denominator, we can factor a m out of the first ones and an n out of the second ones, and we're left with a plus b. So these cancel, and our answer is a minus b over a plus b. Try this one. Okay, so the denominator, multiply these two together, you get 72. What two numbers multiplied equals 72 or added equals 17? 12x squared plus 8x plus 9x plus 6. So I split the middle term, that's 17, into 8 and 9. Factor a 4x out of the first ones, we're left with 3x minus 2, excuse me. Factor 3 out of the second ones, that's a plus 2. And we're left with 3x plus 2. So our factored form is 4x plus 3, 3x plus 2 is the denominator, and then 4x plus 3 is the numerator. Those cancel, and we're left with 1 over 3x plus 2. Now, if you get to a situation where you need to write things in lowest terms, and the difference between them is the second one is the denominator is switched around, we have to list the letters first. Well, the denominator is the same as -1 times -1 minus r. Right? If we multiply the bottom by -1 times -1 minus r, we will get negative makes +1. Oh, I'm sorry, this is +1. -1 plus r, negative makes positive. Or if we rewrote it the other way, we would minus. So this negative sign out front, r minus 1 over r minus 1, this part here is the same as 1. So our answer is -1. For the second one, rewrite the denominator as -1 p squared minus 4. So we have the denominator factors into p minus 2, p plus 2. Still have the same numerator, p minus 2. Remember, they're the negative sign out front. These cancel, and we will have -1 over p plus 2. You try these two. Okay, so we can put a negative out front, a minus 10 over a minus 10 is -1. Rewrite the numerator, negative y squared minus 81 over y minus 9. This factors into y minus 9, y plus 9, or y minus 9. These cancel. And we'll have negative y plus 9, or negative y minus 9 if we took out the parentheses. Try this one. Numerator, we can factor m up, and we're left with m minus 16. Denominator, we can factor negative out. We're left with minus 16. The answer is negative. So, in general, if the numerator and denominator are opposites, then the expression equals -1. Notice if they're not opposite, we can't do anything about it. All right, so what are we going to do if we multiply rational expressions? First of all, we'll factor them. Then we will simplify if possible and check to make sure we have products in lowest terms. All right, for this first one, we can factor c, and we'll have c2. Let's factor the second one. It's c minus 2 squared, right, over c minus 2, c plus 2, and then the second one is c parentheses c minus 1. All right, so our c's cancel. One of the c minus 2's cancels against one of those two, so I just crossed off the squared part. C squared, C squared. This one cancels against the other one. So it looks like we're left with, not so quick, buddy. This is, I didn't see this is C minus 1. So our answer is C minus 2 over C minus 1. All right, this factors into M minus 4, M plus 4. So we can cancel this against this, minus 4 over m plus 2. You do this one. Okay, so the first one, the denominator factors into t minus 2, t plus 2, t squared, 3 parentheses t plus 2 over 9t. Okay, some simplifying then. We can cancel the t against one of those two t's, cancel 9 against 3, and we're left with a 3 in the denominator. Cancel the plus 2 against t plus 2. And our simplified answer is 8t over 3t minus 2. Or the second one, a little bit more complicated. The first numerator factors into m plus 5, m minus 3, m minus 3, m minus 2, m minus 2, m plus 2 is the second one, m parentheses m plus 5. These cancel, these cancel, these cancel, and we're left with m plus 2 over m. This one. Okay, so rewrite the first one as 2 parentheses minus 1 over p, 8p squared, 7 parentheses p minus 1. These cancel against one of these two, so we'll have 16p over 7. Now, sometimes we need to find reciprocals of fractions, so we just invert them. If you multiply a number by its reciprocal, you will get 1. So when we divide rational expressions, we just take the second part and flip it over. 5 over 15p plus 6, and call it multiplication instead. Q minus 6 over minus q squared. All right, so let's do this first. Nothing we can factor out of the first one. The only thing that we can factor is this part right here. We can factor up 3 out front, and we're left with 5p plus 2. So this cancels against this. And it looks like, remember this here anymore, it looks like we have 25 over 18. Yep, 25 over 18. This one, we can factor q parentheses q plus 2 over, I'm going to rewrite this as q plus 5, get them in the right order. Rewrite the second one as negative 3 times q minus 2 over q minus 2 q plus 2. Remember, that way we can switch these two around, which is what we wanted to do. Okay, q plus 2 cancels against that. Q minus 2 cancels against that. So we'll have negative 3 over q plus 5. You try these two. All right, so the first one, 2p squared q, 3p q to the fourth, times p q goes on the bottom, 6p squared q squared goes on top. Let's simplify some p's. These two p's cancel against those two p's. This q cancels this q. Q to the fourth cancels those, two of those, so we're left with a q squared. So we have 3 cancels against 2. 2 times 2 is 4. P squared over q squared. This first one factors, we have to split the middle term. 6, what numbers multiplied equals 6, added equal 5, negative 6. Ooh, what? Added equal positive 5. So it would be 3k squared minus k plus 6k minus 2. So we can factor a k out of the first one, so we're left with 3k minus 1. Factor 3 out of the second ones, and we're left with No, 2 are the second ones. We're left with 3k minus 1. So our factored form is k plus 2, 3k minus 1. Denominator factors into 3k minus 1, 3k plus 1. Okay, let's switch the numerator and denominator here. So this is k parentheses k minus 7. This is 4k parentheses k plus 2. Okay, k plus 2's cancel. 3k minus 1 cancel. K's cancel. K minus 7 over 4 times 3k. All right. Ooh, a triple bogey. Okay. First one factors into 5s plus t squared. What two numbers multiplied equal 12, added equal negative 13. So that factors into 3s squared minus 12st minus parentheses st minus 4t squared. Okay, let's factor out a 3s out of the first one, left with s minus 4t. Factor negative 1 out of the second ones, we're left with, negative t out of the second ones, we're left with s minus 4t. So our factored form is 3s minus t, s minus 4t. And our last one here factors into what two numbers multiply equal 15 or 2 apart. So 5s minus t, nope. 3s minus t 5s plus t. There we go. Yeah, this is going to be negative 2 or negative 5. This is going to be positive 3, so that's why you get negative 2t squared. Over. All right, this first one, what two numbers multiplied equal 12, added equal negative 11, multiplied equal negative 12, added equal negative 11. So I'm going to start down here. 3s squared minus 12st plus st minus 4t squared. Okay, factor a 3s, and you're left with s minus 4t, and then plus t, parentheses, s minus 4t. So our factored form is 3s plus t times s minus 4t. Next one, this factors into t plus 5s, t minus s. And the last one factors into 3s plus t, s plus t. Okay. 5s plus t cancels against one of these two. Let's see. Did we forget to switch this last one around? Yes, we did. So these two should be switched numerators and denominators. I'm going to rewrite the whole thing over down here. 5s plus t squared, 3s minus t, s minus 4t, and now I've got to change those last two around, so it's 3s plus t, s plus t, over 3s plus t, s minus 4t, t plus 5s, t minus s, 3s plus t, nope, 3s minus t, that's supposed to be, minus t, 5s plus t. Okay, 5s plus t cancels against this one and this one, so those are both gone. 3s plus t cancels against this one. 3s minus t cancels this one. S minus 4t cancels this one. And we could have t plus s over t minus s if we would switch these two around.